Okay. Good morning. Good morning, class. All right. Okay. All right. In today's class, please, I'm waiting for you to reduce the noise. Hey, come back. Okay. Okay. Now, the last time we look at the main type of bonds, which are called primary bonds. The reason why such bonds are called primary is because they are the actual type of chemical bond that holds molecules together. This hall is noisy. Please, you do settle down for the lesson so you will not be a victim of circumstance. Please, you settle down for the lesson so we will have a minimal people that will not understand. I hope those of you at this region, you are with us. You can hear my voice perfectly. Okay. I was saying that in the last couple of lectures, I did mention that two types of bonds. The last time we have talked about the covalent and the ionic bonds, which bonds, primary bonds. They are primary main type of bond because those atoms are held together by a main type of bond. Now let me tell you something about a bond, and then when will a bond said to be primary and when will it said to be secondary? Now, if a bond that is holding two atoms hold this atom by either loss or transfer of electron, if one atom transfers electron to the other, or electrons are shared between two atoms, the bond that will exist between that transfer or share is a primary what? Bond. Because we mentioned transfer or share, we have two types of primary bond there, which can either be what? Ionic or what? Covalent. And in that bonding, that is the actual bonding because they are primary, are the main. When we use the term primary, it means main bonding. It means the main word bonding. Because there is a chemical reaction that has taken place. In any of this bonding, is either there is give or what? Take. That's why some movies, where they act love movie, they will use the chemistry between us. That chemistry they are referring to is what? Bonding. Yes. Before bonding will occur, there must be a transfer of electron. Before love will occur, there must be what? A transfer. Either that the guy is giving money and the girl is receiving what? Money. Two things must be involved. I think you know the donor and the acceptor here. Where na more no donor and acceptor. So with the donor and acceptor, it will go chemistry. It will go about body chemistry, which can trigger so many things. Which can trigger the girl to start to love the guy. If the guy is not bringing money, the bond holding them, they can weak Van der Waals force of what? Attraction. Look at the weak. The more money that the guy is giving, the higher the electronegativity. So if bonding is the main aspect of chemistry. Bonding is the reason why some compounds are held together without dissociating. This is not a village. This is not a village. This is not a village square. Now, to secondary bonding. Secondary bonding occurs when primary bonding must have occurred. It's secondary. It's not the main. It happens when primary has what? Happened. That's why it is what? Secondary. Meaning it is not the main. That the main has happened. Now it is the turn of other bonding to what? Happen. Now let me explain this in a simple term. I will not be giving you too much notes to copy. I'll just be doing more of illustration than giving something to copy. So you understand. Now listen to me. Listen attentively. Now, like I said, primary will happen before what? Secondary. Now let me show you something. Supposing that this is water molecule. You know water molecule is like this. That's how it is at the molecular level. That is 2 atoms of hydrogen versus 1 atom of what? Oxygen. Of course, you know the type of bonding that is holding this H here, and O. I think you know what is holding them here. What is holding the 3 atoms together? Covalent. Aquia? Covalent bond. Because you see that hydrogen is very close to the oxygen. That means they must have shared pair of what? Electron. Who can tell me how many bonded electrons are there in a molecule of water? How many bonded electrons are there in a molecule of water? They will give you 2 in option A. And that is not correct. And the answer is what? 4. Have you forget? Which kind of question be that? This oxygen with a low fueke. How many electrons do they share here? 2. How many here? Total of bonded electrons, how many there? 4. I've said it before. And then again, there is something you must also know. That the electron is not shared equally between this atom and this atom. I think I told you that in a covalent molecule, a covalent bond can either be what? Polar or non-polar. Alright, it is polar. A polar bond, a polar covalent bond is if there is an unequal share of electron. Are you with me? If there is an unequal share of electron between the participating atom, the bond that will exist between the atom is what? Polar. And I wouldn't want to use electronegativity to bore you. I don't want to do that. But rather, I will show you something that will help you to understand. I think I will use period 1, period 2, where you will see these relevant atoms. In period 2, you have 1, 2, 3, 4 elements, and so on and so forth. Which element will occupy this position after hydrogen here? Lithium. Which one goes here? Beryllium, boron, carbon, nitrogen, oxygen. Yourself, looking at the position of hydrogen and position of what? Oxygen as in water, you find out that the electronegativity difference of the 2 atoms is what? Is wide. You see how many elements you have to pass before you get to this. You pass 1, 2, 3, 4, 5. Even without using the numbers, you should know that the difference is clear. So because of that, whenever you see O, oxygen, let me draw these things very well so you understand. 1, 2, 3, 4, 5, 6, 7, 8. So this is how the bonds occur. This is what the oxygen we use to make bond with what? Hydrogen, right? So this is the electron of hydrogen. This is hydrogen itself. This is the electron of hydrogen. This is what? Second hydrogen of what? Itself. So you see how it goes now. This bond has how many electrons inside it? 2. Second one is what? 2. That is why I said the number of bonded electron in water molecule is how many bonded electron? 4. That is by the way. So these are covalent bond. But because of this distance, the electron were meant to be equally shared between the two. But unfortunately, the electrons are not shared. The one that is more electronegative will tend to what? To attract the bonded electron. So the bonded electron of this particular oxygen will start to move away. From where? From what? From where? Hydrogen. This one will start to what? Move away from what? Hydrogen. As it moves away from hydrogen, what do you think is remaining of hydrogen again? What is remaining there is what? Proton. Or lose the electron partially. Now after loss of electron now, this hydrogen becomes what? Partially what? Partially what? Positive. For having lost electron. Then the oxygen that gained electron will now be partially what? Negative. So whenever you see a charge between two poles of an atom, that's two partial charge that exists between two atoms in a molecule is called polarity. It's called what? Polarity. And then the bond that you will now use to link the two of them, link the plus charge and negative charge, is called a polar bond. What is a polar bond? It occurs when there is an unequal share of what? Electron between two atoms in a molecule. Oh yeah, be up. Assuming hydrogen shall bond with carbon, the distance is not too much, or not too much. Bond the Hannah and the polar. Rather, the bond between these two will be what? Will be what? No why you? Joy. Okay, for no car we go suppose. Oh, maddening in the mere solar. Look at how you are enjoying fun everywhere. See. To know you are learning in executive suits. Go to a suit. I say you go to a suit. Go to a suit where they have a lecture. You will not see far. You will see a hole like this, even twice this size. No single fan is working. They'll be leaning under that situation. Without microphone. No. Don't worry, you go there now. You go there now. No, there is no TV. For those that are not close to see, you had to struggle. Some see fat half. Some will be outside. They will just be there to write attendance. Just to be attendance to other half your girl we are in a love garden. Okay, that one is by the way. Now listen to me. Now Genti. Now Genti. Now open the guarantee. Iman water secondary bonding. Because this thing that happened here will lead to the secondary bonding. Are you with me? So what has happened now? This side becomes what? Negative. Sorry, positive. The reason why it's positive is because the atom is least electronegative than what? Oxygen. That is a simple truth. Are you following? Are you following? As is in no need against. Only see no kita phone corner happy. Phone corner happy we are. Open kata phone. I say, do you understand? Or say no. It's forget kita. The whole yema. Juvenile can egg soup. Okay, now attention now. Now, listen. You know why electron is moving away here? It will always happen like that. Just take note of this. Periodic table will help you. You know why periodic table will help you? Because if you are moving across the period, electronegativity increases. That is the reason why. You will bear it in mind to be able to know what happened here. So it will not be like I'm explaining it without source. This source is here. And then Pauli exclusion make why very simple. He gave numbers to every element. By the time you leave this place to this place, electronegativity of oxygen is 3.5. Compared to this one is what? 2.1. By the time you do plus and minus and plus, you now find that the difference in the electronegativity is enough to cause polarity. True or false? It's enough. It's enough now. 3.5 minus 2.1. Getting for there. All the more than 0.5, Abi, there must be polarity now. Polarity means development of partial charge. Distortion. I get what distortion. This is what it is. Then the distortion, you're going to now, the distortion now is, here is plus, here is what? Minus. But all partial. They will exist like this. Do you know that any molecule that form this kind of thing, this thing and this thing, go and check it. The boiling point of such molecule now is very high. Because by the time you try to boil the molecule, even now, these two things will be attracting each other. Yeah? This side and this side will be bringing themselves together. In fact, they will bring themselves together to the extent that if you are hitting the molecule, the heat, they will be absorbing it. They will be no weapon fashioned against us shall what? Prosper. They will be coming together. That is why molecules that are non-polar covalent, they tend to have higher boiling point than those that are what? Non-polar. But all of these things are still talking about that this is still covalent. Covalent means that the electrons are still shared, but the electrons are unequal. Are you with me? Now, Akuyama, do you know that a day one molecule now? About a day one molecule. Here for one molecule. What if now molecules of water carry? There were many molecules of water. Now that we have this one, and then we have another one here, another molecule here. O, 1, 2, 3, 4, 5, 6, 7, and then 8 somewhere here. And this one forms another bond here. Okay, it forms another bond here with another O, another bond here with another what? O. What is this in? Okay, this is water, B. This is water. Both of them are covalent. Now, listen. The same thing that happened here will happen here. Okay? This one, this electron will move here, B. And here becomes what? Partially what? Negative. Okay? Here becomes partially what? Positive. Do you know that there is another bond after this bond has happened? And this bond has happened. There's another bond that will link this one and this one. I will represent that bond with broken line. Nenieba, okay, below from here. Because no are positive, only are negative. Positive and negative. Are they like charge or unlike charge? Unlike. Okay, unlike charge, do they repel or attract? Nenia the attraction here. Nenia. Dash, and what? Dash. Now, this thing is linking oxygen. This is oxygen. The attraction is from between what? Oxygen and what? Hydrogen. Abi? Now, this secondary bonding that has occurred between these two molecules, what is it called? This bonding that exists between these two water molecules, what is it called? What is it called? Anyway, many types of secondary bonding. Anyway, hydrogen bonding. Ewe Van der Waals force of attraction. Ewe London dispersion force of attraction. What do you call it again? Oh, metallic bonding. So which particular one is holding this water molecule together? Is what? This is called intermolecular what? Hydrogen what? Bonding. We're getting to now. Now listen to me. Now, this bond, listen to me. In this bond between this molecule and this molecule, is there any share of electron? Did this share electron here? Or there was no share where? Was it any form of transfer of electron? There is no share. There is no what? Transfer. It is not covalent because they didn't share. It is not ionic because there was no what? Transfer. What is it? It is a secondary bond. What is a secondary bond? A secondary bond is a bond that occurs after a primary what? Bond. A secondary bond is a bond that is holding a molecule that has been formed by primary. It holds two molecules together. But why do we choose to name this particular secondary bond hydrogen bond? Why? It is a bonding between what? Hydrogen and electronegative atom. Are you with me now? Which electronegative atom are we talking about here? Are we talking about here is what? Oxygen. Oh, special. All is special. Now, next one, it can only happen between H and what? O. It can happen between what? H and what? N. H and what? F. Because if you look at the periodic table, you will see after O, the next element is what? F. So it is these three elements that are opportuned to be what? Bonded by what? Hydrogen. And that's what they want. The name of the bond is called what? Hydrogen what? Bonding. Yes, want to ask a question? Want to? No. Urinate. We're going to urinate. You just have 1 minute. Now listen. In again. Listen. The bonding. Listen. The bonding will bring this molecule in again and this molecule. Okay, where are they? It will bring this molecule closer. Are you hello? Let me show you. Let me give you an analog explanation to what happened here. If something is solid, what does it mean? If something is solid, what does it mean? It means that the molecules, how do you see these molecules? The molecules are closely what? Packed. Are you with me? Now, if a molecule, if a matter is liquid, what does it mean? It means that the molecules are what? Are not closely what? Packed. Do you get the point now? So now, let me now explain this thing to you now. Because of this bonding, this molecule and this molecule will come this closer. That is why the standard state of water, is what? Is what? Liquid. A drug an exam. KML water. What is the reason why the standard state of water is liquid? Because let me show you something here. Who can tell me the next element that is beneath oxygen in the periodic table? Aqua sulfur. It means now hydrides of this group should behave alike. Hydride of oxygen is what? Water. Hydride of sulfur is what? Hydrogen what? Sulfide. Hydrogen sulfide exists as gas, but H2O exists as what? Liquid. What if we are asked to explain the anomaly or the abnormal for the two hydride of the same group to occur or exist at different what? State? Who can explain the anomaly between the H2O and H2S? To why one is a gas and one is what? Liquid. Who can tell me? Look at the answer here. What's the answer? Because of what? Intermolecular hydrogen bonding. Yes, that reminds me. I told you that I'm going to summarize 17 topics for you. I've done with the summary. I think I'll just give you a tips of how the questions we look is still under the process. In fact, with this thing, I told you we just prepare. You use it to prepare JAM for 24 hours. 17 topics in 24 hours. A cover child. As is in a power. Niya buno see I will go on the jump on your behalf. Oh, trap and set till haga the anemia. And when you puna gent also get a boni boko in a hall and boko no way ma. A good bed up to 2 topics. A body like an Adam Sagaba. Ibutifa like this. It question about the over 200 questions. Abago muhonya. Will a bag is also no escape routes. In the bar now, because also only 40 questions are here. Then you pour 200 and something. In all the topics, they will not escape. Look at what I mean by that. Oh, when they had Jubugo, when they Akagaju. Who question there? Some of you don't know. Had you on the question now? Some of you may not even have any clue to answer it. For example, you already know this, that hydrogen gas is not found in the atmosphere. Sure, you know. It's not found in the atmosphere. What did they ask you? It's not found in the atmosphere due to dash. See how this book is analyzed. I will not even give you the option. I will just give you the answer and then explain to you why. So, you can't have hydrogen. Hydrogen as a topic is there. But so with this thing now you have summarized that particular topic. So now see, answer to that is because it readily reacts with oxygen. That is the answer. The reason why it can't exist in the atmosphere is because it readily reacts with what? Oxygen to now form what? Water vapor. Are you with me now? So you see it as water vapor, not as what? Hydrogen. Because it readily reacts with who? Oxygen. Then this one has come out a couple of times. See, helium is preferred to hydrogen in filling balloon. Have you seen such question before? Do you know that hydrogen is lighter than helium? Do you know? Hydrogen is the lightest gas known. Are you aware? But imana gas CG fill a balloon is not supposed to be helium, but what? Hydrogen. But why are they using helium instead of hydrogen? Yes, look at me. Why are they using helium? They are not even attempting to use hydrogen that was supposed to be preferred. Let me tell you the simple truth. Hydrogen is the only gas that is flammable. I can't make flammable. Do you know you can use flammable and inflammable? They mean the same thing. What is flammable? Something that can what? Something can catch what? Fire. What is inflammable? Something that can also catch what? Fire. You can use flammable as what? Inflammable before matabele interchangeably. That's why if you see some of this long truck carrying petrol or carrying all this LNG, come here LNG. LNG. That is liquefied natural what? Okay. What is the constituent of LNG? What gas is used as LNG? But your neighbor also no hydrogen. So get, excuse me. So actually, the constituent of a natural gas is what? Methane. No, nyamia. Onyamia. Or the now. The constituent of a natural gas is what? Methane. Oh yeah, what? Doesn't look what there. But what about the main constituent of natural what? Gas. Oh yeah, LNG. Hydrogen is the only gas that is what? Flammable or inflammable but does not support combustion. Hello? Okay, man, even something inflammable. Something can catch fire, but it can catch fire, but it does not support combustion. Why? Why? Who can tell me? Eh? I should answer it. Or we put a question on Zazie. That means what if you are here? Imani buso koko. Imani di tara koko at 20. Ini di ki wota koko at 20 pieces. Genti. On una that na gas na the lighter than air cannot support combustion. Hydrogen is less dense than air, so it cannot support combustion. But it is what? Flammable. Wagenti. Open you hydrogen fill a balloon. Balloon geju. Okay, man. Balloon have in yoga suspender where? We can almost charge a balloon. Or Waals, showing that the gas is what? Flammable. So, although advisable to use it to fill balloon. Hello? The answer is hydrogen is flammable. Because helium is both light and non-flammable, unlike hydrogen that is flammable, though less dense gas known. If you got that, with this thing, Imutagifa. Okay. When you get one sodium compound, they make glass. One sodium compound that they make glass. Aluma glass in a favor. Maria, Mangwagia, or Naupa. Our papa be there, we're going to come. Check our papa. Say, it's boomia, it's boomer. Wagenti, Sebuko again a photo. I got man fear. Who can tell me a metal whose oxide is used for production of colored glass? When I'm able to color glass. Glass is enough for chacha blue. What in a beam? Okay, one metal oxide used in making that color glass. I got you get this. One metal oxide used in making color glass. Is this glass colored? In the case of the natural blue. Okay, metal oxide ajaria. Can we just dash again? One metal oxide that make color glass is cobalt 2 oxide. Cobalt. Over cobalt, bichon. Okay. Who can tell me cassiterite is the ore of which metal? Cassiterite. Can you spell all again? C-A-S-S-I-T-E. Cassiterite. C-A-S-S-E-T-E-R-I-T-E. What is the ore? The metal that has this ore? Cassiterite is the ore of tin. Is the ore of what? Tin. 1 mole of a substance contains dash. 1 mole of a substance contains dash. What does 1 mole of a substance contains? You say it contains Avogadro's number of what? 6.02 times 10 to the power what? 23. In which process does coal give coal gas, coal tar, ammoniacal liquor, and coke? In which process does coal give coal gas, coal tar, ammoniacal liquor, and coke? Which process do coal give this 4 process? It is what? Destructive what? Distillation. It is here. And in company akwale gi 4 book iwike motia. The common compound used in fire extinguisher. The common compound used in fire extinguisher should be what? Is what? Carbon 4 what? Oxide. Who can tell me the property carbon 4 oxide that made it used as fire extinguisher? The property of the gas that made it useful as a fire extinguisher. Can you get one property here? Okay, property melage use CO2 as fire extinguisher. Something that can quench fire. Something that is not combustible. What property makes it a fire extinguisher is because the gas is heavier than air. Is here. If we're gonna have the revision, no revision ever. Some of you will be like, they want to see this thing. If you see this thing, let me tell you, your jam problem is almost solved. It took me months to research this thing. Let me hold it very well so it doesn't miss. Who will tell me this one? The most reactive halogen is dash. Is here. Well, who can tell me this one? A non-metal that exists as liquid at room temperature. I give option A. They say a non-metal that exists as liquid at room temperature. I give mercury option A. A dalo wegi down from of. I didn't option. I do my option. Can't talk gabo. Oh, we win the pin now. No answer ever. The answer is what? Bromine. Bromine is liquid, not metal. Just like mercury is a liquid what? Metal. Only here. Who can tell me product form when chlorine is added to slake lime? When you add chlorine to slake lime, it's what? Bleaching powder. Whatever. Yes. Who can tell me the constituent of gunpowder? Gunpowder. The constituent. Constituent means what is inside gunpowder. Here, German shebwe. Whatever. It means shebwe. You need the charcoal. Charcoal number 1. Sulfur number 2. And the potassium trioxide 35 is number 3. Actually, which compound is used in the manufacture of gunpowder? Which compound? If you go for sulfur, it's wrong because sulfur is what? Element. If you go for charcoal, it's wrong. Charcoal is also an element. Do you know? Charcoal is an element. Do you agree with me that charcoal is an element? Shut up. What do you mean? It do often happens at times. You know, a mechanic man, after working with a brain box, working with a washing engine. You know, all the grease particles, you know, the hands will be what? Will be all filled with what? Grease. Okay? Now, let me tell you something. The mechanic man will not wash his hand with water. He will not wash his hand with water, but he will wash his hand with petrol. That is jump question. That is jump question. Why is he going to, if he see the mechanic kagemali yourself? Okay, but with him. I'm coming to Omo, don't worry. Omo will commot it. Omo will commot it. I'm coming to why Omo will commot that one. Well, listen to me. The reason why the mechanic will not wash that hands filled with grease with water, if you try it, the water melts on the grease, or death chapel. If you don't fear, if you know what you acquire from now to tomorrow, that thing will not be removed. But the moment you just get some quantity of kerosene and just put there, everything becomes clean. Why? Have you forgotten that grease is a petrochemical? Petrochemicals are hydrocarbons. Kerosene is also a hydrocarbon. Both are non-polar. According to rule of thumbs, what does it say? It says likes dissolves like. So why are you using water to wash the hand? It cannot be washed. Then somebody say water for Omo. No. In the case of Omo or soap, imana soap no more abrof. Both of them are detergents. Apozino Omo eba. Ina Omo ina emerundo Omo adverts. Because Omo brand. Ichi gwame sim detergents. Can I merundo ukipuzo go clean. So I will not call anybody name. So if we perceive we are beginning detergent, what is detergent? Detergent is something that can bring cleansing, something that have cleansing action, something that can remove what? Stain is what? Detergent. Anything that can remove stain is called what? Detergent. Omo can remove stain. Are you with me now? What else can remove stain? Soap. Imana soap. Now, imana with soap and soapless. Are you a new student? They want me to hammer you now. I said I don't need this. Whoever that wants question should indicate. Make a microphone so that you will not come and insult me with your letter. You want to say something? You must say something. Okay. Okay, I know what you're saying, but you go chari off ma. You go to chari off ma. So, having as detergent, it were two types. It were getting soapless. Imandable soapless. Soapless, but they now be in form of powder or liquid. Now in form of powder is what you call Omo. Okay? Then be liquid, no, it can come as liquid, you know, liquid soap. All those things are soapless. Then soapy, bundana with shape. Okay, but shape now solid. And then the solid. A powder because solid. So I'm and then the way shape, bogini soapy. In Africa, soapy and what? Soapless. There are two different types of detergents. There are two different types. One is made from vegetable oil. Between soap and soapless, which one is made from vegetable oil? Soap or soapy. Soapy is made from what? Vegetable what? Oil. Through a process we all know as saponification, which means alkaline hydrolysis of what? Vegetable oil with what? Caustic what? Soda. Who can tell me the byproduct of saponification? Who will for one other thing important as byproduct? Who can tell me them? There is one thing that goes away as byproducts after soap is formed. When you bubble caustic soda with vegetable oil. There's one alcohol that is released as waste products. Who can tell me the name of the alcohol? All the common now. Openly, man, it's not for that compound, but glycerol. Pure. But him and that was pure glycerol. Afia was a propan 1, 2, 3 triol. That was the That's the byproduct. In fact, the reason why it is called byproduct, immediately soap are formed. That particular waste product are removed from the soap. Do you know how it is removed from the soap? It is removed by a process called salting out of soap. Salting out. The salt used in salting out of soap is called what? Sodium chloride. Maybe organic soap. Organic. Are you? Organic 2. Organic 2. In fact, it's like I'll start organic 2 tomorrow. Because I want time. I don't know what else. I must be angry because the head of the soap contains carboxylic ion and sodium ion. That 2 ions are called hydrophilic head. The part of soap that is soluble in water. Even a soap with 2 parts. Unama. Every head, we're going to tail. The tail of a soap is hydrophobic. Unama, hydrophobic. Phobic means hate. Or like milli. And all that that hydrophobic tail is what removes oil stain from clothes. Uwe kamano sitege na clothes kita. A drug in exam. Which part of soap remove oil stain? Is it the head or the tail? The what? The tail. Am I worried about the tail? The tail is non-polar. That is why it is soluble. The head is what? Polar. That's why it's what? Soluble. The oil, is it polar or non-polar? Oil is non-polar. So which part of soap will dissolve the oil? The tail. The tail. The tail. I've explained this, that the solubility of ethanol in water is due to what? Intermolecular what? Hydrogen bond. I want to ask this simple question here. Glucose, is it soluble in water? This one you're not saying time up. I'm even scared. You're not saying time up. When I listen to me, Ima, get it. Can't go and check it now. Two compounds, so the organic. In comparison. C6H6. I think you know it's benzene. I've got benzene. C6H12O6. What is it? Glucose. Are you aware that glucose is soluble in water, but benzene is not soluble in water? Are you aware? The solubility of glucose in water is because of what? Do you also know that because of what? Hydrogen what? Bonding. Do you know what is glucose? Glucose is a polyhydroxy compound. Compound with many hydroxy groups. What is the chemical name of glucose? You know it is 2, 3, 4, 5, 6. Okay, yes. 2, 3, 4, 5, 6 pentahydroxyhexanal. Only break. Break.